Have you ever stopped to think about where we really come from? What if the key to the origin of life isn't found here on Earth, but out there, drifting in space for billions of years? What if everything we know about our existence is just one small piece of a much bigger cosmic puzzle? Recently, NASA's OSIRIS-REx mission brought back something extraordinary: samples from the asteroid Bennu. And when scientists began analyzing them, they found something that could completely change the way we understand the formation of life on our planet. These fragments revealed a surprising amount of organic molecules, key ingredients that may have played a crucial role in life's emergence. But what does this discovery really mean? Could the origins of life itself be extraterrestrial? In today's video, we're going to dive deep into this revolutionary finding and explore its mind-blowing implications. And trust me, you won't want to miss a second of this, because what we're about to discuss could redefine our understanding of where we came from and whether we're truly alone in the universe. The OSIRIS-REx mission was launched in 2016 with a bold and ambitious goal: to travel over 320 million kilometers to reach Bennu, a near-Earth asteroid believed to hold secrets from the very beginning of our solar system. Scientists selected Bennu because its composition has remained almost completely unchanged since its formation, essentially making it a cosmic time capsule, one that could give us clues about the early chemistry that led to life. Bennu was expected to contain organic molecules and hydrated minerals, compounds that could help us understand how the chemical building blocks of life originated and evolved. But there's another reason Bennu is so fascinating. It's one of the most closely monitored asteroids in our solar system because it has a small chance of colliding with Earth in the distant future. Understanding its structure and composition isn't just a matter of scientific curiosity. It could be crucial for planetary defense. Over the course of the mission, OSIRIS-REx not only mapped Bennu in stunning detail, but also achieved something historic. It successfully collected physical samples from its surface. This was no easy task. In October 2020, the spacecraft performed an extremely delicate maneuver known as tag, touch and go, where it briefly touched Bennu's surface to scoop up material before beginning its long journey back home. After nearly 3 years of traveling through deep space, the capsule containing these priceless samples finally landed in the Utah desert in September 2023. Scientists wasted no time and immediately began analyzing the fragments. And what they found exceeded even their wildest expectations. The samples revealed a treasure trove of organic molecules, including amino acids and nucleobases, fundamental components for the formation of life. Even more astonishing, scientists identified minerals that formed through interactions with liquid water, suggesting that Bennu may have undergone chemical processes similar to those that occurred on early Earth. If these essential ingredients for life can be found on an asteroid like Bennu, what does that tell us about the possibility of life elsewhere in the universe? Could life, as we know it, have started from cosmic seeds carried by asteroids and comets? The implications of this discovery are nothing short of revolutionary, and we're just beginning to unravel the mystery. These discoveries strengthen an intriguing hypothesis: the building blocks of life may have come from space. But what does that really mean for our understanding of life's origins? The detection of organic molecules in Bennu's samples adds weight to a fascinating theory: panspermia. This idea suggests that essential compounds for life could have been delivered to Earth by asteroids and comets that crashed into our planet billions of years ago. If that's the case, then these life-forming ingredients might be scattered throughout the universe, making the existence of other inhabited worlds much more likely. And Bennu isn't the only asteroid where organic substances have been found. In 2020, Japan's Hayabusa 2 mission returned samples from the asteroid Ryugu, which also contained molecules linked to life. These findings support the idea that the chemistry of life can naturally emerge in different parts of the cosmos. So, what makes Bennu special? The presence of water in its samples suggests that this asteroid may have undergone chemical processes similar to those that occurred on early Earth. This opens new doors for understanding how the first building blocks of life could have formed and evolved in extraterrestrial environments. If the ingredients for life are so abundant in space, could distant planets have developed their own unique forms of life? The discovery of Bennu, along with similar findings in other asteroids, has sparked debates about whether space rocks might not only create the conditions for life, but also help spread it across the cosmos. Imagine that, at some point in the distant past, an asteroid collided with a faraway planet, carrying essential organic molecules and setting the stage for life to emerge elsewhere. This possibility is pushing scientists to look at asteroids as potential targets for future space missions. If we can find the building blocks of life on celestial bodies like Bennu, there's a good chance we could discover something similar elsewhere in our solar system, or even on distant exoplanets. Missions like Europa Clipper, which will explore Jupiter's moon Europa, and the Perseverance rover on Mars, are working to better understand how life might arise beyond Earth. However, not everyone is convinced. Some researchers argue that the molecules found on Bennu and other asteroids might simply be the result of natural chemical processes, with no direct connection to life. For these skeptics, the presence of amino acids and nucleobases isn't proof that life started beyond Earth. It could just be a byproduct of carbon and water-rich environments in space. Still, the discovery that essential molecules for life are common in space is a huge win for those who believe life in the universe might be far more widespread than we ever imagined. These findings not only open new doors to understanding the origins of life on Earth, but also have massive implications for future space missions. OSIRIS-REx was a milestone, but it's just the beginning. Soon, missions like Dragonfly, which will explore Titan, one of Saturn's moons, will push our knowledge even further, helping us understand what it takes for life to thrive beyond our planet. Titan, for example, has lakes of liquid methane and a thick atmosphere, making it a prime candidate for studying the possibility of life based on completely different chemical foundations than those found on Earth. If the basic ingredients for life can be found in asteroids, then the search for habitable environments on moons and planets is about to heat up. Beyond that, OSIRIS-REx's discoveries bring new perspectives to asteroid exploration. These space rocks could become prime targets for future sample return missions, not just to unlock the secrets of our solar system's past, but also for their potential resources. This could pave the way for asteroid mining, and even using these celestial bodies as stepping stones for deep space exploration. In the end, OSIRIS-REx's impact goes beyond science. It challenges us to see space not as a distant, unreachable frontier, but as a natural extension of our existence, one full of possibilities for the future. If the fundamental ingredients for life are present in asteroids like Bennu, we could be standing at the edge of a revolution in our understanding of the universe. The discoveries made by the OSIRIS-REx mission show that space isn't just an empty void. It's a place filled with potential to unlock the mysteries of life. Thinking about the possibility that life itself might have started from cosmic fragments leads to one big question. What if we're not alone? If these building blocks of life are scattered throughout the cosmos, could there be other inhabited worlds out there? Or at least planets with the right conditions for life to emerge? The future of space exploration has never been more exciting. With every new discovery, we get closer to answering one of humanity's oldest questions. Where did we come from? And are we truly alone in the universe? What do you think? Could life on Earth have started from a seed that came from space? Drop your thoughts in the comments, and let's keep this conversation going.